Paolo. Okay, so today we will explore the complexities of environmental sustainability, and Paolo Ferrari and Pim Mossert will guide us along the way. So this webinar will begin with a brief presentation of the BroilerNet project, which is coordinated by Stefan Gunnarsson, who I see here among the participants. And we will then continue with an in-depth look at litter management and the reduction of ammonia emissions. And then there will be an analysis of the impact of the ECC on greenhouse gas emissions. Later on, there will be an interactive question and answer session. So please, if you have any question, just feel free to write them in the chat, and I will take care of that. So if you have any questions, just share your thoughts with us. So this webinar will begin, as I said, with a brief presentation of the BroilerNet project. So I present myself. I'm Annunziata Palamara. I'm a researcher for CRPA, which stands for Research Center for Animal Production, which is a research center based in Reggio Emilia, Italy. And today I will show you the main findings from the third consultation round of the BroilerNet project related to environmental sustainability. So first of all, what is the BroilerNet project? It's a EU-funded project under the Horizon Europe program, and it is actually coming to an end in July 2026. This project is coordinated by the Swedish University of Agricultural Sciences. So what's the purpose of this project? Actually is to provide knowledge and solution in order to help farmers and stakeholders in addressing future challenges. So the main focus, the main point is to improve sustainability and management in the broiler sector. So these improvements are related actually to three key dimensions. So environmental sustainability, animal welfare, and animal health. So from an environmental perspective, broiler systems are linked to high GHG, so greenhouse gas emissions, land and water use, and pollution issues. So these factors raise serious concerns, so especially in the context of climate change and resource scarcity. Second, regarding the animal health risk, there is the high stocking densities that can increase the risk of disease transmission, which often lead to the use of antibiotics. And as you of course know, this contributes to the antimicrobial resistance. Finally, the animal welfare concerns, so like the limited space and restricted expressions of natural behaviors can cause stress and negatively affect animal well-being. So it's important to proceed with an holistic approach, so to involve all these dimensions if you want to improve something. So there are 25 organizations involved in this project, and they are from tier 2 countries. Here you can see the map and all the logos. So there are many people involved in this project. So who are the actors of this project? We can define three group of people. So the BNF, the beans, and the TENS. So the BNF, which stands for Broiler Network Facilitators, are people who are in charge to collect good practices from farms. So they have to support knowledge exchange, and they work on a field level. Then there are the beans, which stands for Broiler Innovation Networks, and they are national poultry expert groups. So each country have a beans group. And they have to propose new challenges and solutions related to their own country. And so, of course, they work on a national level. Finally, there are the TENS, which stands for Thematic Expert Networks, and they are international expert groups. So they their duty in this project is to select key challenges and identify the winners, and they work on international level. As you can see on the right, there is a picture which I took during a a meeting with the beans in Italy. So here you can see the structure of these selection procedures. So first of all, the beans. So the national expert groups have to identify the national needs. So have to ask themselves what are the needs of the farms. So what we have to improve. So they propose these challenges to the TANs. So they propose the challenges on an international level, and the TANs then select the key challenges. Right after that, the beans again have to propose good practices related to these key challenges, which are related to, as I said, environmental sustainability, animal welfare, and animal health. One important information factor is that these practices are based on real farm data. So actually there is someone who applied this practice. Then after being proposed good practices, the TANs again evaluate the good practices and choose the winner. So then finally we have the BroilerNet champion. So regarding for each consultation round, there are different challenges. So for the third and last consultation round, there are two challenges for each team. So for environmental sustainability, animal welfare, and animal health. So regarding the environmental sustainability, the first challenge is the being proposed and then the 10 selected is reducing ammonia emissions. So ammonia is a major concern because it affects both the environment and animal welfare and, of course, human health. So as you can see on this slide, ammonia related to poultry led to related to poultry, but in general, I mean, can contribute to soil acidification, eutrophication of water bodies, also biodiversity loss, and also to the formation of fine particulate matter. These fine particulate matter. So it deals not also with health, but also with animal health, but also with the humans. So in broiler production, ammonia mainly originates from nitrogen excreted in droppings, and when litter moisture is high, microbial activity increases, and ammonia is released into the air. So emissions are influenced by several factors, like including diet formulation, ventilation, temperature, humidity, and litter quality. Of course, there are different mitigation strategies, like litter moisture, like keep litter moisture under 30%, optimized protein levels. But I don't want to go deeper in that argument, as I know that Paolo Ferrari in his presentation will show you different mitigation strategies. But one key message that I want to share with you is that you cannot achieve environmental sustainability without reducing ammonia emissions. So this is an important message that I want to share with you. So then the other challenge that was proposed by the BIN and selected by the TANs was improving carbon auditing, so establishing baseline and standards. So carbon audits at farm level are essential to identify GHG emission hotspots. So this activity is also important in order to support targeted mitigation strategies in broiler production. By analyzing data such as feed use, energy consumption, or manure management, or I don't know, housing systems, farmers can better understand where emissions originate and how they can deal with it, how they can improve that. So it's important to highlight that current carbon calculators, so these tools are often heterogeneous. So they differ in methodology, system boundaries, and underlying scientific assumption. So this actually limits comparability between farms. So it's that's the main point. I mean, but moreover, many tools are primarily evaluated based on usability and speed of adoption. So they don't care about the quality, but the quantity, actually. These, of course, translate into a less attention to the technical robustness, data quality, and scientific evaluation. Of course, you cannot reduce, that's the key message of this challenge. So you cannot reduce what you cannot measure properly. So that's the main point of this challenge. So related to that, our beans proposed different challenges, and the TANS selected two champions, so one champion for each challenge. So for the first one, for the reducing ammonia emission, a French practice was selected as the champion, so optimizing litter aeration and addition for ammonia emission reduction. So this practice actually focuses on keeping poultry litter dry and friable throughout the production cycle. This by combining early aeration with targeted addition of fresh material. Of course, we will go deeper into that into the issues during the webinar. For the second challenge, so for improving carbon auditing, the TANS selected this German practice, so standardized carbon accounting for livestock production. Here you can see the fact sheet. So the Manure Farm IFA grower group developed a calculator for farmers and in order to track improvements, benchmark performances, and identify environmental and financial savings. Here you can see, as I said, the fact sheet as we for each good practices we produced a fact sheet and an abstract. So you can find these things, this kind of documents on our website. So here you can see our homepage, the BroilerNet homepage. As I said, I will share the link in the chat. On our website, you can find inspiring best practices and hands-on tools, and also the latest news and event updates, like this webinar, the next webinar. So as in the next month, there will be also other webinars and events related to the BroilerNet project. Of course, you can find multilingual resources and key publications, as every document is, of course, translated in different languages. Of course, there will be there always will be a document in English. So don't worry. And then you can also find stories and experiences from farmers and experts. So please visit our website. You will find like everything. So thank you for your attention. My presentation is done. So I think, Paolo, you can continue this webinar. So please feel free to share your screen and also present yourself, as I didn't do that.
Okay. Sorry. No, we are still looking to your, I think.
Oh, sorry.
Okay, good.
I was sharing.
Now it's possible.
I was still sharing, sorry.
Right. Good. In presentation mode, just a moment. This. Okay, almost done. Okay,
It's
should
not
be
in
okay.
presentation mode right now.
Is that okay?
Yeah.
Perfect.
Yeah.
So thank you, Tina, and hello, everybody. And this presentation is about litter management and reduction of ammonia emissions. I will show you, what are the main mitigation strategies in relation to this kind of emissions. And also, I will illustrate the best of the good practices that were selected according to this challenge. And you'll see, then I also will show, I will talk a little bit about the top 5 good practices, which were analyzed, scored, and selected by the experts, international experts, which were contributing to this important part of the job, the discussion. And then I will show you the one good practices practiced by a French farmer, able to reduce, to limit the ammonia emission and improve the litter quality and also the welfare of the birds. So, as we know, ammonia, so 39% of ammonia emission at global level are caused by livestock farming. And so ammonia emission is considered as a major atmospheric issue due to that influences the global environment and the major environmental risk to human health and also for the animal health, as it contributes to the formation of secondary particulate matter, and also ammonia is causing issues to the respiratory tract and also make the birds more sensitive to respiratory diseases. So, and as regards ammonia, if you look to the Directive 207/43 about the welfare of broiler chickens, broiler farms authorized for high stocking density over 33 kilograms of live weight per square meter. The concentration, air concentration inside the bird should not exceed 20 part per million ppm, and to this end, they should provide evidence of the ventilation equipment able to provide, and also other technical information in order to get this authorization. Ammonia emission, as said, has an important impact on the environment due to the formation of PM, particulate matter, indirect contribution to nitrous oxide, which is a very powerful greenhouse gas, and causing eutrophication and acidification. The origin comes from birds' droppings degraded in the litter, but particularly comes from the losses of nitrogen from feeding the birds. And emissions so are influenced by the diet, so we should limit the nitrogen content so the protein content in the diet, in order to avoid any surplus, any losses in the droppings, in order to ensure that the protein in the diet is retained by the bird body, by the body growth. So it is also affected by the litter quality, of course, by the temperature, humidity, acidity, so the pH. So if the pH is high, ammonia emission is higher as well. And ventilation. Ventilation is very important in order to keep the litter dry, to reduce the humidity, and in this way to limit the ammonia emission. At the same time, it shouldn't be too high, particularly in the winter time, in order to, because ammonia is emitted due to the contact, the interface between air and the drops and the fermented litter. So mitigating strategies. The main mitigation strategies, which are all also mentioned in the BAT reference document, I will show you it later, and are related to optimized protein levels, litter management, so the moisture, the humidity should be kept below 30%, improved ventilation, and as said, the indoor ammonia concentration should be kept under the level of 20 ppm in order to preserve human and birds' welfare and also to preserve bird growth performances. The main stages of the production of broiler production are mentioned in the BREF, so the best available technique reference document for intensive rearing of poultry or pigs. And this is a document which is very important for the authorization. Every broiler farm keeping more than 40,000 birds must have this kind of authorization. And in relation to ammonia, we have three different stages. So the housing, so the emission inside from the litter, we can say, during the production cycle, the eventual treatments of the litter at the end, after the birds has gone to the slaughterhouse, the storage, so the litter, the manure can be stored, and we have emissions as well. And during distribution, also we can have large emissions, as you can see here in these figures. Powerful mitigation strategies are, for instance, not looking to the house, but looking to the inside the house, we have two kind of technologies which are mentioned by the BREF, and are acid scrubbers that are able to reduce by 92%, up to the 92%, the ammonia emission inside from the house, and compost filters up to minus 70%. And another important mitigation strategies is when we apply the manure to the soil. And it is very important to incorporate directly, very soon, the manure into the soil instead of spreading on the soil. And of course, if on the soil it is exposed more to the air, and then ammonia emissions comes up. And so these are very powerful mitigation strategies. Unfortunately, acid scrubbers and compost filters are expensive strategies, and this is the reason why they are not so common nowadays. But there are many data, and there are models of this equipments available on the market. The main problem is the cost. And so also, if we put together mitigation strategies from the house to the storage and to the soil application, we can reach mitigation, which we can reduce up to 90% of total emissions of ammonia from the house. So acid scrubbers are able to catch ammonia by putting in touch the ammonia in the air with sulfuric acid, for instance, and in this way we can produce ammonium sulfate, which is a very good fertilizer also. See if it will, we collect that, we have this kind of solution that we can use also for vegetable crops. And yeah, compost biofilter. Yeah, this is not the core topic of this presentation, but this is another way of treating the air, exhaust air, in order to reduce the ammonia, but also we can reduce the emissions of particulate matter and the reduction of odor. You can find a lot of information in the brief about this kind of reduction of the impact thanks to these strategies. So as said, diet strategies are the first step in order to reduce emission of nitrogen in the droppings, and then the fermentation, and then ammonia emissions. So there are these are only some examples. You can see here that lowering from 90 to 70% of the core protein between day 0 and day 21 improve retention of nitrogen in the bird's body by 7%. And thanks to this improved retention, we can see that we can achieve a reduction of ammonia emission from the litter. So this value can go up to 35% as reported in the brief. So when coming to litter management, so for what are the main strategies to keep to have a good quality of the litter and to reduce the ammonia emissions? So as we said, yeah, litter quality is affected by the kind of litter that you are using, by water spillage from the drinking plant, for instance. So it's very important to control and to avoid such kind of water losses on the litter. Litter aeration, so you can do that with a certain treatments, mechanical treatment, and litter addition in the wet area, in the area where the moisture is over 30%, and we can have ammonia emission. So litter sources. The top choices are wood shadings, especially from pine, and dehydrated rice hulls, and pelletized or chopped straw. Alternatives can be chopped straw, sawdust, peanut salts, and sand, but require careful monitoring for caking and humidity control. And also additives can be used, like zeolite is highly effective for reducing ammonia through absorption, while amendments like sulfates, alum or sodium bisulfate can reduce the pH and then reduce ammonia emission. So water spillage control should be done daily under the nipple drinkers. You can see here also the drip trays are useful, are a little bit more, not difficult, take longer for cleaning them, but however, they can reduce the spillage of the water on the litter. So the leakage should be fixed promptly. The pressure should be regulated in order to avoid too much pressure inside the line and install water meters for monitoring alarms in case of leaks. So this is very useful. Of course, you can put these water meters and they monitoring, and if there is a spillage, there is an alarm, and you can go there and fix leakage promptly. Deterioration and addition. So litter is initially spread, usually in a layer of 5-6 centimeter thick, over the entire usable surface. And this surface should be concrete, and it should be dry and preheated. This is very important to keep the litter dry, particularly in winter time on the humid, cold season. Litter aeration should be started by means of mechanical scarifier or cutters, so machine mixing, however, and mixing or cutting the litter in order to get it more aerated. What is important is not to turn it. Turning the litter is good to have a better mix, but it results very often to ammonia emission. So what is important to break eventual crust on the litter and to keep that aerated and to add more litter. And so this mechanical scarification or mixing should be done every 2 or 7 days according to the seasonal humidity and ventilation flow. and after 1-2 weeks after the chicks are housed, and up to 4-5 weeks. And additional litter is spread to keep the litter dry and wet areas. So the best litter is the litter which a very high absorption, capable to absorb water. And unfortunately, the pelletized litter and pelletized straw is expensive, more expensive than normal straw, and also wood shavings, particularly the high quality wood shavings with dehydrated, are more expensive than normal straw, of course. But it is very important, the choice of this kind of materials. So, and now I would like to show you what are the 5 good practices that were selected by our experts in relation to this challenge. And the first, the top, the winner, the champion was the title was Optimized Litter Aeration and Addition for Ammonia Emission Reduction. I will show you it, but before I would like to tell you what are the other 4. We have ammonia emission audit for broiler farms, and this is an auditing system, and it was proposed from a Greek farmer. The use of improbed to reduce ammonia emission, and this is a mix of straw, 80% and 20% of we said before, bisulfate, in sodium bisulfate, which is a powerful acidifiers, and so it is a product that you can buy. And then we have the good practices 4 and 5, which are about optimizing amino acid balance in broiler diets in order to reduce protein content and, of course, the content, nitrogen content in the droppings. Okay, so this is the winner, David Labbé from France, and it is not very big farm. They have 2 broiler houses with 27,540 chickens per batch per broiler house. They produce 6 batches per year, usually, but in 2004 a little bit less. and they produce heavy broilers, males at 3.3 kilograms when they are 45 days old, and females slaughter lighter at 1.9 kilograms when they are 35 days old. What is the practice? The practice is to aerate, steer the litter every 5 days from start, from day 0 up to approximately 20 days by using a scarifier machine. So a machine which is cutting the litter, but not turning it. And generally is done under the drinker lines and not throughout the entire building. And it has to be done early enough and regularly to prevent the release of ammonia. It is recommended to not wait that a crust is formed in the litter, as it will stir up even more ammonia when it will be open and moved. What is important not only to the mechanical aeration, but also the litter addition. So regular addition of litter is carried out during the batch cycle, allows for maintaining litter quality. And in wet or caked or damaged area. So in this farm, they start with 2 kilograms per square meter for day-rated wood shaving at day 1. And they add 2.7 kilograms per square meter of chopped straw only in caked degraded area on days 7, 14, 21, and 26. And you can see in these pictures the litter before adding, during adding, you see the chopped straw here, and you can see here how, the quality is improved, particularly near the drinkers, under the drinkers. What is very important also the ventilation. So this farm is equipped with, of course, ventilation, but they have also this system for monitoring temperature, humidity, also the looks inside the barn. In different locations, they have different sensors, and you can see that the temperature variation you can check. And you can see these green lines. When there is a problem, they turn into red lines so that the farmer can be alarmed about something wrong, and it can manage the situation through the ventilation. So not only litter, but also ventilation is very important. And you know that ventilation is very different from in winter time. You have to keep the heat inside the burn and to reduce the ventilation, but at the same time you have to extract the humidity efficiently. Whereas in summertime you have to extract the heat and with the high flow ventilation, and if you do that, also the usually the moisture is taken out. So, what are the environmental economic benefits of this practice? We have better litter quality, less powder dermatitis, and less ammonia emission. Increased labor time for putting added litter and using the scarifier machine. Higher cost for purchasing and maintaining the scarifier, and higher cost for buying additional quantity of litter of high quality. Compared to only straw used as litter at the beginning, without any addition and without any scarification, mechanical mixing, and so on, a mixture of wood shaving and chopped straw results in higher average daily gain, improved feed efficiency, and lower mortality. The farmer estimated a gain, an additional gain, economic gain of around plus 10% due to improved litter quality and annual performance. However, in this project in BroilerNet, the Polish partners is doing the CBA, the cost and benefit analysis of this in more precise way, and able also to simulate the implementation of this practice in small, medium farms in all the 13 countries. Of course, it is a simulation, but it is very interesting to know these outputs to provide information to the farmers of what could be the impact of this practice in their country, not only in France. And you can see here on your left, you can see the fact sheets. This is a draft, but it's going to be completed very soon. And on your right, you can see the EIP abstract, which was delivered to the EU Farm Book system that you can use to look for and analyze good practices or results of operational groups, research projects, and so on in relation to this topic. Thank you very much. So I will give you the floor to you, Tina, and in a way that you can present PIM presentation. I will.
Yeah.
I take out. Oh, good. Okay.
Yeah. Thank you, Paolo, for this interesting presentation on this truly problematic gas. As I can see, also someone commenting on the chat that it is actually a really big problem. So I invite you all to feel free to share your thoughts. I mean, this webinar is not only for us to talk to you, but only you have the chance to talk with us and share your what do you think about that. So now I give the floor to Pim Mostert. So please, if you want to present yourself and share the screen.
So in the meantime, I would like to say that this farm also, you can see in the leaflets, was get a bonus when the pododermatitis was under a certain threshold. So it was the slaughterhouse, their clients were able to provide the farmer with a bonus. So it was boosted, it was stimulated to do better, to improve the litter quality, not only to reduce ammonia emissions, but also to reduce pododermatitis and general health of the birds. And this is one of the reasons why these additional efforts were compensated economically in a way to have a gain to improve the profitability of the farm. Sorry, Pim, the floor is yours.
Thank you. Do you see my screen?
Yeah.
Yes, perfectly.
Presentation mode.
Yes, thank you. First let me introduce myself. My name is Pim Mostert. I'm from Wageningen University in Research. I'm a researcher in environmental analysis of the livestock sector. And for today, I will present the impact of the European Chicken Commitment Broiler Production System on greenhouse gas emissions. I will first short introduce what is the European Chicken Commitment. I think most of you are aware already of that, but just a short catch up. The main important message from here is with the European Chicken Commitment wants to adopt higher standards on broiler welfare. And a lot of companies in Europe committed to that, also in the Netherlands. But of course, it's all well known, higher welfare standards can, of course, have trade-offs for your economics or your environmental performance. And that was the goal of this study. What we wanted to do, what is the impact of the ECC on economics? We also looked at food safety, antibiotic use, and the environment. For the environment, we look specifically at greenhouse gases, land use, and phosphorus excretion. Today, I only focus on greenhouse gases, mainly because of the time constraint. But the good news is, if you want to know more about it, it's all reported in the report you see here. There's a link also available. And also, if you're interested in the economics and the food safety, you can all find it published in the report. So for today, the focus will be about greenhouse gas emissions and where we compare the ECC compared to conventional. So just why is this important? And it's good to well, when we talk about greenhouse gas emissions, government has set goals. It's the Paris Agreement. We have legislation. Different countries have different targets. What you see here is the target of the Netherlands. So we want a reduction in 2030 compared to 1990. And that's about the emissions that occur in the Netherlands, and every country has set its own goals for that. In the next slide, I will explain why that is important. The focus is for the government on the Netherlands, but you of course has also the companies. They also have to report either the CSRD, which recently has been scaled down a bit, but still some companies have to report about their emissions. And also, you see worldwide a lot of companies committed to the Science-Based Target Initiative, in which they also set targets for reduction in emissions. And what is the main difference in when you compare what companies for targets have and the government? As I said before, the government focus on the emissions that occur in the Netherlands, in our case then, or your own country. And why is that important? Because when we look at poultry production, feed production and related emissions to feed production are very important to the total emissions in the poultry. And in the Netherlands, main feed ingredients are important. So that means that greenhouse gas emissions do not have a high contribution to the total emissions in the Netherlands, because those feed ingredients are important from other countries. Of course, for other environmental impacts, that's different. For example, for ammonia, etc., that's more important, the poultry sector. But for greenhouse gas emissions, not so many emissions occur in the Netherlands. When you look at what companies do, they follow the life cycle assessments. They also take the emissions into account that occur outside, in this case specifically the Netherlands. So they take the chain approach. You can also call it the scope 3 emissions that occur from outside their direct production. And that means you include feed production emissions, and then means that's what you can do, an LCA. And then, of course, the poultry sector is very important because, feed production is the main source in greenhouse gas emissions. So it's good to realize when you talk to the industry or the government about the greenhouse gas emissions, they have different type of interest in reducing those emissions. For the poultry sector in this case then, of course. So what did we do? With a typical broiler farm, and based on the performance of an ECC chicken broiler production system and a conventional broiler production system, we had the input for both systems from field data from farms and industry, or earlier research, or we had it from databases, for example, about energy use. And we also used some data from a research station in Belgium for the comparison of the ROS and the repo. So what we did, again, as I said, a life cycle assessment, and we compared the total emissions from an ECC system and a conventional system. So we include all the emissions along the chain until the slaughterhouse. So we started with the breeder, the rearing and the laying period, to the hatchery, to the broiler farm, to the slaughterhouse, and in between there are transport and products get out, for example, meat and other eggs from the laying period. And in the end, we have a kilogram. Well, we express all those emissions in kilogram live weight, kilogram carcass weight, or kilogram meat. I come back later to that. To calculate that, you need a lot of input about production parameters, but also about emissions along the chain. So you need the feed production, the feed compositions and emissions for producing all those feed ingredients, and then the transport, etc., processing to the Netherlands. Based on what methodology to do that, we published before in the Greenwell project. We also calculated for slower growing chickens, the environmental impact that's already available, you see that. But now we also in the Netherlands, we see, it was also addressed before in the presentation, a lot of different methodologies how to calculate emissions. And in the Netherlands, we're now developing a standard for the Netherlands, a carbon footprint guideline standard, in which, we say how to calculate it, but also what primary data needs to be collected. And if you cannot have those primary data, what default values you should use, and also what background data sets you should use. Ideally, again, that's from a European perspective, but that's not yet possible. But if you want to see exactly how we did it, you can read it back in those reports. I'll not go into detail that because of the time. Very important, as I said before, is the type of diets. So for the breeding states, we composed one diet for the rearing and one diet for the laying. In this case, we assumed the same diets for conventional and the ECC for the breeding states. But for the broiler states, we had 4 diets for both of them differently. And the selection of the feed ingredients for these diets were based on the nutritional recommendations by the breeder organizations, and based on, it's good to realize, based on economic optimizations prices of 2024 for the Dutch situation. Then, of course, we needed to have the greenhouse gas emissions related to those feed ingredients, and these were either from AgriFootprint or AgriBalise with the trade mix to the Netherlands. So that means, for example, if you soybean meal, that can come from several countries. So that was included, including the emissions from those different countries. But of course, we also needed the performance data. What you see here is the main importance for here. This is about the broiler states. In the report, you can also read for the breeding states, because we said the diet is the same, but the production performance data was a bit different in the breeding states. But you can find it back in the report. So we compared the ROS with the red row, and you see the main differences is here. For this, most important for you now to remember, there were more difference, but for difference to understand the difference in greenhouse gas emissions, the mortality and the feed conversions are the most important differences. What you see here, and these are the ones that we took in this report. And also, of course, the slaughter weight and the kilogram meat was also different, and that was based on data we got from the Hubbard and the ROS 308, and then we compared those two, and we said that the red row was in between those two. Just for your information, again, you can all read it by detail back in the report. But what you see here is that the carcass yield is a bit lower. So the red row is the ECC, and also the kilogram of meat is a bit lower of the red row compared to the ROS. And that's important to understand the results when you express emissions per carcass or per kilogram of meat. So kilogram of meat is the breast, legs, and wings together. So when you look at the feed emissions, so we composed those diets for the breeder and for the broiler states. You see here for the breeder it was the same, but you see here for the conventional and ECC with 4 different type of diets. So the composition was also different, and the main difference what you see here, so you have to compare, for example, the starter of the conventional with the starter of the ECC, etc., for the grower and finisher. The main difference what you see here is in land use chains, so it's a bit lower at the ECC broilers. Also, the total is a bit lower, and that's again mainly to the land use change emissions, and those were a bit lower because of a lower inclusion of soybean products. And these soybean are again based on trade mixes. So if you would assume all those soybean products would come, for example, from North America, the land use change emissions will be very low. But in this case, also a big part comes from South American countries, which result again in land use change. But it's important to see here that per kilogram of feed, the HSA broilers have a bit lower emissions, mainly due to land use change. But if you're going to express that into the broiler farm, you see here the kilogram CO2 per kilogram live weight at the broiler farm stage. So that includes the breeder. We also have it at the breeder stage, but you can find that in the report. The breeding stage to the total is limited, as you can see here. That's the dark blue part. But you see the main emissions are related from feed production and from land use change. So per kilogram of feed, the ECC broiler had a bit lower emissions, but when you express it per kilogram live weight at farm, you see it's higher, about 6%. And that's again because the feed conversion rate it's much higher. So that reduction in feed production per kilogram does not outweigh the feed conversion rate. And of course, I come back to it later, you can debate how to include that land use change, but you see here in general, the emissions from the ECC are higher than the conventional. So you can also express that per kilogram carcass weight or per kilogram total meat. So if you look again at kilogram live weight, the increase of the ECC is 6.3. If you would look at the carcass weight, it's about 7.2. So the carcass weight of the conventional is better than the ECC. And also, as you showed you before, at the total meat, it's better at the conventional compared to the ECC. So that results again in a higher increase of the ECC. So these results are also there for economics and other environmental impacts. And when you look at the other environmental impacts, you see the same trend that the ECC performs per kilogram of product worse than the conventional. So an important question is always what people ask, how now to reduce those emissions, and it's quite clear that at the broiler you have to focus on the feed production. That's different, for example, when you compare to pork or dairy sector. Dairy sector, of course, has enteric fermentation or the manure storage. Also at pork, manure storage is an important one. But specifically when you look at greenhouse gas emissions and poultry, the focus should be on feed production. And then the most easy way, always, when you look at those results, you think, hey, I should do something about my land use change emission, change my origin of feed, for example, go from South American soy to North American soy. And yes, that would give a good result for you on paper. In theory, when you look at a broader food system, not only at your broiler farm or country, or only the broiler sector, but as the livestock sector, you're only shifting emissions. As long as the total demand for feed ingredients remains the same, you're just shifting emissions from one farmer to another farmer or from one sector to another sector. So on paper, yes, it would work, but the question is, do you really solve something on a global perspective? I don't think so. Just the one who's first in North America has the one without land use change, and the one more or less has the one from South America with the high land use change. Then, of course, you can also think, hey, we should have different feed ingredients. Yes, that can work very well. But again, you have to think about availability. You see a lot of focus on byproducts or products from the food industry that's mostly have a lower carbon footprint. Yes, that can give, again, for a broiler farmer, a lower carbon footprint. But again, you also have to think about, is it available? Is there enough available to feed a lot of poultry farms with that feed ingredient? And also, where was that feed ingredient coming from? Are you getting it from the pork sector? Was it already there? And again, are you shifting emissions or are you not shifting emissions? So again, when you look at different type of feed ingredients, you always have to think, yes, my emissions go down, but when you look at a broader system, do I really solve something, or am I just shifting emissions? And I'm well aware it's very difficult to know that, because before you know, you're looking at the whole world. But what is definitely working is doing something on the cultivation and the processing. So there's a lot of fossil in there. So reduce that. In the cultivation, you can reduce that, but also in the processing, go to different type of sources. There's no trade-off in that going to green energy or improving the yield during cultivation or other cultivation practices. But also that will have a price. And you also need to think, yes, as I'm a broiler farmer. My product comes from Brazil or another country in Europe. How do I manage that? It's a bit far from a slaughterhouse to go to feed ingredients in different part of the world, and also be aware: is it possible for them to do that? Because it will have a high cost, and there might be also other issues in other countries which are much more important than changing their cultivation practices or going to green energy. So it's not easy, but the good thing about it is there's no trade-off in improving cultivation and the processing. Of course, you can also look at other impacts to reduce those emissions, but they are minor. Yes, manure has some impact, but on the total emissions, it's limited. Again, this is for greenhouse gas emissions. For other environment impacts, of course, you should do something about the manure. Also, energy is relatively low compared to the total. Of course, it's always good to go to green sources. But if you really want to reduce emissions, you should do something on the feed production. So to conclude, the feed production is the most important to reduce the total. But what we showed here is that the ECC has higher greenhouse gas emissions per kilogram than the conventional. Although per kilogram feed it was a bit lower. That's mainly because the higher feed conversion for the ECC. So yeah, there's clear trade-off here, I think, between improving the animal welfare, but increasing the impact on greenhouse gas emissions. That's what I want to conclude. That was it. If there are any questions, feel free to ask them now, or read the report, or send an email later if you want. Thank you.
Thank you, Pim, for this interesting presentation. Actually, there is a question for you from Bertrand. You can read it in the chat. So, is the 6% difference based on average values, or did you perform an uncertainty analysis?
No, that's an average value. So yes, in practice, you might find probably a lot of variation in there.
Okay. So there is another question from Saad. My question is that you look at CVP kilogram meat, while ACC gives much lower yield per year compared to standard chicken. So the SPP will be even higher overall.
I'm just trying to read the question well.
Or maybe we can ask Saad to intervene and take the floor, and maybe to explain this question.
Yeah, sure. Sorry about my voice. I've lost
Cool.
it.
Thank you very much. No problem. Please.
Yeah. The question is, of course, when we talk about carbon footprints per kilo, that's one thing, but the yield over a year, for example, standard chickens can give 6 cycles. ECC might give 4 or plus minus whatever numbers are. So we are just looking at the carbon footprint per kilogram meat, but overall in the year, you are getting much less yield for meat, for example. So how do you compensate those numbers instead of just reporting carbon footprint per kilogram of meat or carcass yield? I hope
Okay.
that.
Yeah, thank you. It's clear now to me. So basically, you can scale it up to the total amount of meat produced. Then you have the total emissions difference, of course, and that will be in percentage the same. But of course, if you want to produce the same amount of meat, you based on the ACC, you need to build more stables, which is not included here. So yeah, if you would assume we all change to ACC with the same amount of stables, then we have a lower total production of chicken meat. Is that a clear answer to your question? Oh, yeah, I see. Thanks.
Okay, are there any other questions? Feel free to turn on the microphone if you want.
Just a comment, we can say, Pim, your report is very interesting, and also it was following a previous report that was committed by AVEC to ADAS, and it was less detailed, maybe in taking into account the region of the protein from South America, from deforestation or not, and but they also highlighted the problem of if we reduce the stocking density, we need to build up new poultry houses, which is not that easy, particularly in the short time, and this is a kind of impact, of course, and it has also some impact economically and politically and so on. At the same time, we have to say that broiler meat is the cheapest meat in Europe, and so it's and also there is a good self-sufficiency in broiler production in Europe, and so when we talk about self-sufficiency and in the global market, so it is an important asset for livestock in Europe. So it depends on the timing, of course, but yeah. However, thank you also, Sard, for this question. Maybe there are some other questions from somebody in a written way, so in the chat or in by introducing yourself and taking the floor. Yeah. Any comments, also questions or comments or additional information that you would like to add in the discussion? We don't see it. Please, Pim, would you like to say something?
Yeah, I see some comments from Bertrand. I think his name.
Yeah, good. There are new ones. So, Tina, we would like to.
Yeah, maybe Bertrand, you can open your mic, as I think they are statements actually.
It would be better. That's always the challenge of doing some environmental analysis. The question of metrics, the metrics that you are using is always raised. Of course, LCA is using the classical kilogram functional unit, but that's, as I was saying in the chat, in regions where you have a lot of livestock, you also have to consider what is the not the footprint per kilogram, but the footprint of a farm, of a group of farm over the territory, because you have a lot of nutrients that are lost, phosphorus, nitrogen on a local scale. And I think it's quite interesting also to consider what is on a given territory the footprint of this production on the territory, and I think it quite change a lot the conclusion if you change the metrics. And the ECC system is probably will probably have a lot of impact, because you decrease quite a lot the amount of meat that you produce each year. So that means that on a local view, considering the local burden, let's say, or footprint, it will decrease compared to let's say a standard production system or a high producing system. So from the view of public policies and public actors, it can be also something that is quite important to discuss. It's a matter of trade-off between the performance of the system itself and the performance of the system and the effect of the system in its environment, local environment, I think.
Yes, thanks, Bertrand. I completely agree with you. But I think this was the focus on greenhouse gas emissions, and I'm also aware for good discussion we should have a broader environmental impact analysis than only the greenhouse gas emissions. But I think for greenhouse gas emissions, I think it's logic to look at per kilogram of product. It's commonly used because it's a global problem. But I agree for local environmental issues, it would be more logic to look at the different type of units per farm, for example, because you have local environmental issues. And then if you have a lower total production, yes, the local N excretion or P excretion might be lower, and therefore lower environmental impact also. But that was not the goal of this study. It was the focus was on on greenhouse gas emission.
I think that more precise, not more precise, more focus, more studies based on the available knowledge, but more studies focused on specific supply chains or specific territories could help also policymakers to address their policies, and in order to improve the sustainability of livestock farms, particularly broiler farms, of course. But now so there are a lot of debate about the carbon footprint calculation and impact calculation and trade-offs, and so it is very complex matter. And but the kind of study that you did, Pim, together with your colleagues, are very helpful to have a better overview of what are the possibilities, of course. Yeah. Is there any other, Tina? Is there any other question?
No, there aren't. So,
of course, we are open. Yeah.
No, I don't know. Maybe if there aren't any questions, we can close this webinar, but there is still time. So if you want to say something, I don't know.
Still this is the time. This is the moment. Yeah, exactly. No, otherwise you can get in touch with the speaker and with the BroilerNet to make network, so you can get in touch with us, with the coordinate with the other partners to get more information and the project. Stefan, please, yes, your intervention is very welcome.
I would like to express my sincere thank you to Tina and Paolo and to Pim for giving interesting presentations, and it's really nice that we have such a large audience and that we can distribute information that is valuable for people within the broiler sector. on all levels, from scientists to farmer, and from farmers to scientists. Thank you.
Thank you, Stefan. So, well, that's it. I think we can close this webinar. What do you think, Paolo?
So we would like to
Okay.
thank you, all the people, participants, the speaker, Pim, of course, and his colleagues for nice presentation and nice publication, and a very important, very interesting topic nowadays. And I think that, of course, I would like to tell all the people that the webinars, not only about environmental sustainability, but also to other two topics faced by the BroilerNet network, animal health and animal welfare, are available. The recording are available on the website, so you can look at them, and also you can download a lot of materials of the all good practices that have been collected, the best ones, of course, the top 5, and you can find thematic reports that you can download, including references, scientific and technical references to that. And and we hope, of course, that it will be helpful to make the European poultry sector more competitive and sustainable, of course, in the future. So, for you, Tina, last.
Thank you, Paolo. So just one last thing. So the recording of this webinar will probably be published on our website next week. So you'll find there anything, as already Paolo said. I want to thank, of course, Paolo Moster for his important contribution. We really appreciate it. And also to Stefan for joining us today. So thank you all. Thank you all for joining us today. And I wish you a nice weekend. It's Friday today. So thank you all. Have a good day. Bye, everybody.
Bye-bye.